Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to see a tidbit of Legendre's equation and an example problem. So let's get going. Legendre's equation. An equation of the form ax plus b power n into d power n y by dx power n plus p1 into ax plus b power n minus 1 into d power n minus 1 y by dx power n minus 1 plus so on plus p n y equal to q is called Legendre's equation, where p1, p2, so on, pn are real constants. Okay. And this q is a function of x. Okay. An equation of the form ax plus b power n d power n y by dx power n plus p1 into ax plus b power n minus 1 into d power n minus 1 y by dx power n minus 1 p2 ax plus b power n minus 2 into d power n minus 2 y by dx power n minus 2 plus so on plus p and y equal to q is a Legendre's equation, where p1, p2, so on, pn are real constants and this q is a function of x. Okay. So whenever you are asked to solve an equation of this form, we'll just reduce this to linear differential equation. We'll reduce this to linear differential equation with constant coefficients. By making some substitutions, we'll substitute, or otherwise we'll replace ax plus b with e power z, right? From this we'll get z equal to log of ax plus b and theta equal to d by dz. Okay. Ax plus b, then ax plus b into d will be a into theta ax plus b whole square into d square can be replaced by a square. Say when you get square, you'll get a square into theta minus 1, and for cube, that is ax plus b whole cube into d cube, can be replaced with a cube into theta minus 1, theta minus 2, and so on. Okay. By making these substitutions, we can reduce the given Legendre's equation to linear differential equation with constant coefficients. Okay. Let's see an example. We can call this as Legendre's equation or Legendre's linear equation. Okay. Now coming to an example. Let's say an example problem. Solve 2x plus 1 whole square into d square minus 2 times 2x plus 1 into d minus 12 into y equal to 6x. So this is of ax plus b whole square into d square plus of some constant, say p1 into ax plus b into d minus some constant into y equal to some function of x, right? So by noticing 2x plus 1 whole square, 2x plus 1 power 1, we can say that, so this is of Legendre's equation form, right? Given differential equation, which look like Legendre's equation, right? 2x plus 1 whole square into d square minus 2 times 2x plus 1 into d minus 12 into y equal to 6x, right? Now consider as equation number 1. We are given a Legendre's linear differential equation. Now we will reduce this to a linear differential equation with constant coefficients by making some substitutions. We know that from Legendre's procedure, ax plus b equal to e power z, right? Then z equal to log of ax plus b and theta equal to d by dz, and here we can make a substitution, or we can just replace by substituting this. We'll get ax plus b into d can be written as a into d, and ax plus b whole square into d square can be replaced by a square into its theta, okay, a theta of theta minus 1, and also ax plus b whole cube into d cube can be replaced by a cube into theta of theta minus 1 into theta minus 2, right? In order to change the Legendre's equation to linear equation with constant coefficients, we'll make the substitution, right? So this is the known thing, but from our problem ax plus b is 2x plus 1, right? We have 2x plus 1, right? Let 2x plus 1 equal to e power z. From this we'll get z equal to log of 2x plus 1, right? And we'll replace, theta is nothing but d by dz, and also we can replace 2x plus 1 into d by a, that is 2, coefficient of x is 2, right? So I'll get 2 into theta, and 2x plus 1 whole square into d square can be replaced by 2 square, since it is d square, right? This term whole square into d square, so we can replace this by 2 square into theta of theta minus 1. It's a formula, okay? You just need to remember that. Fine. Now coming to the problem. 1 becomes, now we'll just replace this. 2x plus 1 whole square into d square can be replaced by 2 square into theta minus 1 minus 2 into 2x plus 1 into d can be replaced by 2 theta. So you'll get into 2 theta minus 12 into y equal to, you're having 6x, right? Here we'll get some function of z. Okay. So we have 2x plus 1 equal to e power z, right? From this we can find x, right? We can write this as 2x equal to, take this 1 to RHS, then you'll get e power z minus 1. Now take this 2 to RHS, you'll get x equal to e power z minus 1 by 2. So from this you got x, which is e power z minus 1 by 2, right? Now the RHS part becomes 6 into, replace x by e power z minus 1 by 2. You'll get e power z minus 1 by 2 here. Okay. Now this equation becomes 2 square is 4 into theta minus 1 minus 2 into 2 theta is 4 theta minus 12 into y equal to 3 e power z minus 3, right? 3 into e power z is 3 e power z minus 3 into 1 is 3. Now let's simplify this. We'll get 4 theta square minus 4 theta minus 4 theta minus 12 into y equal to 3 e power z minus 3, or 4 theta square minus 4 theta gives minus 8 theta minus 12 into y equal to 3 e power z minus 3, right? Consider it as equation 2, which is in operator form. Say f of theta into y equal to some function of z. Okay, let it be r. Okay, which is a function of z, say. Function of z or a constant, whatever. Okay, function of z. Here we are having function of z and a constant. Okay, fine. Where f of theta is 4 theta square minus 8 theta minus 12, right? So now we have reduced the given differential equation or Legendre's equation to a linear differential equation with constant coefficients, right? Fine. Now we'll just solve this by using any of the methods which we have used to solve the linear differential equation with constant coefficients, right? Fine. Now we'll find the solution to this equation 2, and the general solution is given by y equal to yc plus yp. We'll find yc using auxiliary equation, and we'll find yp using 1 by f of theta into the RHS part. I'll call it as r. Okay. So firstly we'll find the solution to this equation 2, and later we'll replace that z or e power z, whatever that comes in z, in terms of x, and then we'll get the general solution to our given equation. Okay, let's go for it. Firstly we'll begin with auxiliary equation in order to find yc, and later we'll go for yp. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta 4 theta square minus 8 theta minus 12, right? Let's replace theta by m so that we will get f of m equal to m 4m square minus 8m minus 12, right? Then the auxiliary equation becomes 4m square minus 8m minus 12 equal to 0. Now take 4 common from all these terms. We'll get 4 times m square minus 2m minus 3 equal to 0. This gives us m square minus 2m minus 3 equal to 0. We need to find factors to this equation. We'll just write minus 2m as minus 3m plus m minus 3 equal to 0, right? Now take m common from the first two terms. We'll get m times m minus 3 plus m minus 3 equal to 0. Now take m minus 3 common from these two terms. We'll get m minus 3 into m plus 1 equal to 0. Now equate each factor to 0. When m minus 3 equal to 0, m equal to 3, and when m plus 1 equal to 0, m equal to minus 1, right? This gives us m equal to 3 and minus 1. The roots are real and distinct. Therefore, m equal to 3 and minus 1 The roots are real and distinct. Therefore, yc equal to, we know that when two roots are real and distinct, say when m1 and m2 are real and distinct, then yc will be one constant into e power one root into variable. So here z is our variable. In equation 2, z is our variable, right? Theta is nothing but d by dz, right? So z is our variable here. Instead of x, we'll write z here. Plus c2 into e power another root into z. Now our yc will be c1 into e power 1 root, say 3 into z plus another constant into e power another root minus 1 into z. This gives us c1 e power 3z plus c2 e power minus z. Therefore, yc equal to c1 e power 3z plus c2 e power minus z. Right? Now we got yc. Let's now find yp. Or we can write this as c1 e power 3z can be written as e power z whole power 3 plus c2 e power minus z can be written as e power z whole power minus 1. Okay, fine. Now we'll find yp. Particular integral is given by 1 by f of theta into r. This equals to 1 by f of theta is 4 theta square minus 8 theta minus 12 into r. That is the RHS part of equation 2. 3 e power z minus 3. Right? Then yp equal to 1 by 4 theta square minus 8 theta minus 12 into the first term of r, that is 3 e power z minus 1 by 4 theta square minus 8 theta minus 12 into 3. Right? This equals to 1 by 4 theta square minus 8 theta minus 12 into 3 e power z minus 1 by 4 theta square minus 8 theta minus 12 into 3. You can write 3 as 3 into 1 and you can replace 1 with e power 0 into z. Since e power 0 can be written as e power 0 into z, and we know that e power 0 is 1. So we can just replace 1. This 1 by e power 0 into z. Right? Fine. Now we can write this as, just take this constant outside, you'll get 3 times 1 by 4 theta square minus 8 theta minus 12 into e power z minus, here also we'll write this as 3 into 1 by f of theta 4 theta square minus 8 theta minus 12 into e power 0 z. Just like the problem we have solved in linear differential equation with constant quotients, here also we'll solve this problem. Okay, in place of x we are having z, in place of d we are having theta. That's the difference. Okay, instead of d and x we are having theta and x. Sorry, theta and z. We have f of theta equal to 4 theta square minus 8 theta minus 12, right? Here we'll find f of 1. F of 1 equal to, just replace this theta by, since it is e power az type, right? E power az type. So we'll find f of a, that is f of 1. Just replace theta by 1, you'll get 4 into 1 square minus 8 into 1 minus 12. This gives us 4 minus 8 minus 12, which is equals to 4. Minus 8 minus 12 is minus 20, which is minus 16, non-zero, right? Since f of 1 is non-zero, we can just replace theta by 1. Okay, now coming to this problem. Here also we have f of theta equal to 4 theta square minus 8 theta minus 12. Let's find f of a, that is f of 0. This is equals to 4 into, replace theta by 0, you'll get, right, then 4 into 0, 0 minus 0 minus 12, which is minus 12, non-zero. Since the denominator becomes non-zero by replacing theta by 0, so we can just apply theta by 0 in this term, and here also by applying theta or by replacing theta by 1, the denominator becomes non-zero, so we can substitute or replace theta by 1. Okay. Since f of 1 is not equal to 0 and f of 0 is not equal to 0, this becomes 3 times 1 by, just substitute theta or replace theta by 1. Okay, coefficient of z 1. We'll get 4 into 1 square, 8 into 1 minus 12 into e power z, minus 3 into, here also, since f of 0 is not equal to 0, just replace theta by 0. We'll get 1 by 4 into 0 square minus 8 into 0 minus 12 into e power 0 z. Okay, this gives us 3 into 1 by 4 minus 8 minus 12 into e power z, minus 3 into 1 by minus 12 into e power 0 z. This gives us 3 into 1 by 4 minus 8 is minus 4 minus 4 minus 12 is minus 16 into e power z, minus 3 into, you can write this as minus 1 by 12, and e power 0 z is e power 0, since e power 0 z is e power 0 and e power 0 is 1. So you'll get 1 by minus 1 by 12 here, right? This is equals to 3 into 1 by minus 16 is minus 3 by 16 into e power z, minus into minus plus 3 by 12, or minus 3 by 16 into e power z plus 1 by 4. Therefore, yp equal to minus 3 by 16 into e power z plus 1 by 4. We got yc and yp. Let's now find the general solution of equation 2 using y equal to yc plus yp. Therefore, the general solution to equation 2 is given by y equal to yc plus yp. Then y equal to yc, c1 e power 3z plus c2 e power minus z plus yp is minus 3 by 16 e power z plus 1 by 4, right? Therefore, y equal to c1 e power 3z plus c2 e power minus z minus of 3 by 16 into e power z plus 1 by 4 is the general solution to the reduced equation, that is equation 2. Okay, but we need to find the general solution to the given equation, right? So, we'll just replace z, or we'll just replace e power z by 2x plus 1, or if you have any z, you'll replace z by log of 2x plus 1. We'll see that. Okay, now we have y equal to c1 plus e power 3z plus c2 e power minus z minus 3 by 16 e power z plus 1 by 4, right? We can write e power 3z as e power z whole cube plus c2 into e power minus z can be written as e power z power minus 1 minus 3 by 16 into e power z plus 1 by 4. Right? Now just replace e power z by 2x plus 1. We'll get y equal to c1 2x plus 1 whole cube plus c2 2x plus 1 power minus 1 minus 3 by 16 into e power z plus, sorry, we have to replace e power z, right? So here you will get 3 by 16 into 2x plus 1 plus 1 by 4, which is the required general solution to the given problem, that is equation 1. Okay. Therefore, the general solution to the given equation that is equation 1 is y equal to c1 into 2x plus 1 whole cube plus c2 2x plus 1 power minus 1 minus 3 by 16 into 2x plus 1 plus 1 by 4. This completes the problem. So we have seen what is Legendre's linear equation or Legendre's equation in this video with an example. I hope you'll understand. We'll see you in the next video. Until then, bye bye.